Dear students, in today's session, we are going to learn about an important chapter called motion in a plane. Now, this chapter includes three important concepts. One, vectors, the other, projectile motion, and the third, uniform circular motion. So let's start with the important topic, vectors. In vectors, what we are going to learn initially is a vector addition. Now, when two identical vectors of magnitude p and q, they act at a point making an angle theta. So theta is the angle between the two vectors and p and q is its magnitude. And when we add, we get a third vector which is called the resultant, and that can be measured using the law of parallelogram of vector addition. And R is the magnitude of the resultant. So what is the relation between the resultant and the individual vectors? So R is equal to root of p square plus q square plus 2pq cos theta. So this is a very important relation because in every chapter we come across vector, and whenever there is a vector addition, we use this particular formula, which is root of p square plus q square plus 2pq cos theta. R is also a vector. But there are other equations which are more important than this, that is the special cases. Now, which are those special cases? If theta is 0, if theta is 0, the two vectors, they act along the same direction, and then we get the maximum resultant, which is R max, which is the sum of the individual vectors. And when theta is equal to 90 degree, that is when the two vectors are perpendicular, and we get the resultant R to be equal to root of p square plus q square. You can even find the direction of this resultant using alpha is equal to tan inverse of q by p. And then when theta is 180 degree, that is when the vectors are opposite to each other, they act opposite each other, the resultant is a minimum, which is either p minus q or q minus p, whichever is greater. If p is greater, it is p minus q. If q is greater, it's a q minus p. So these three cases are very important. In all these cases, we even find the direction as well. In the first case, the direction of the resultant is along the given vector. Here, the direction is already given by the equation alpha is equal to tan inverse of q by p. And in the last case, the direction of the resultant is always along the greater vector. If p is greater, this is p, this is q. If p is greater, then the resultant will be along p. And if q is greater, the resultant will be along q. And if they are equal, then we get zero resultants, or in simple, we get what we call a null vector. So this is the resultant of two vectors, of which we also call it as the addition of the two vectors. Now, what if the two vectors are equal? If the vectors are equal, then the resultant is given by an important equation, which is R is equal to 2p cos theta. So highly used equation, and this is applicable only if p is equal to q. Otherwise, this equation is not applicable. So what about the direction? The direction is theta by q. So we have certain special cases to remember out of these, which is again very useful in a lot of numericals that we come across in the entire syllabus. That is, if theta is equal to 0 degree, then what is the result? If theta is 0, we get cos 0 here, so the resultant will be equal to 2p. And the value of alpha will be again 0 only. If theta is equal to 60 degree, so we get cos 60 by 2, which is cos 30. Cos 30 is sine 60, which is root 3 by 2. This 2 will get cancel, and thereby you will get root 3p, and alpha will be half of this 60, which is 30 degrees. Or the resultant always bisects the two vectors. If the two vectors act in a particular direction, the resultant will be exactly midway between the two. And if theta is equal to 90 degrees, so we get cos 90 by 2 cos 45, which is 1 by root 2, and here we have 2 by root 2 is root 2, so therefore it will be root 2p, and then alpha will be 45. When theta is equal to 120 degree, when theta is 120 degree, cos 120 by 2, which is cos 60, and cos 60 is half, this 2 will get cancelled, and thereby you get the resulting to be equal to p, and then alpha is half of 120, which is 60 degree. And then finally, when the angle between the two vectors is 180 degree, cos 180 by 2 cos 90, which is 0, so you will get 0 resultant, and here alpha, so since it is a 0 vector, we get a null vector which has arbitrary direction. So if you remember these cases, a lot of numerical, where when the vectors are equal, can be resolved or can be solved very easily. So for example, so if I take a triangle here, and if there are two identical charges are there, plus q and plus q, and when I measure an electric field, we are going to get a direction like this. So is the electric field and some equilateral triangle. So again, due to this positive charge, I'm going to get an electric field which is identical, which is, and now what is the resultant? So two identical vector theta. So this is 60, this is 60, this is also equal to 60 degree here. And when two vectors make an angle of 60 degree, you can see it's a 60 degree, it's a root 3p. So therefore the resultant of these two will be root 3p. So we don't have to waste time in finding the resultant or using the general form. So keep in mind that this entire table is applicable or useful only when the vectors are identical. So that is the main condition under which these equations are used. So this is about the addition. Now, when we take a single vector and when we split into two or more vectors, we get what we call component, and this is called resolution of the vector. So this is again one more important tool which is used in a lot of numericals. So I'm going to consider a vector. So let this vector be a, and I want to split this into two components which are perpendicular to each other, and we call it as a rectangular components. So if this is f, and if I take that angle theta with the horizontal, then the horizontal component, which is fx, f along the x-axis, becomes a f cos theta. The other component, which is along the y-axis, becomes fy, and that will be equal to f sin theta. So fx will be equal to f cos theta, fy will be equal to f sin theta. Now, what is the relation between f, this fx, and this fy? The relation between f, fx, and fy is f is equal to square root of fx squared plus fy squared. And when we divide these two equations, we get tan theta, and that will be equal to f will get cancelled, and thereby you get fy by fx. So we can relate the angle made by the vector with the components, as well as the components can be related using f is equal to root of x, fx squared plus fy squared. And most important that these components are equal. Fx will be equal to fy only when theta is equal to 45. So do remember this one of the important point, that the two components are equal only when theta is 45. You can check that. So cos 45, which is 1 by root 2, so it's f by root 2. Sin 45 is also 1 by root 2. So therefore, here we get fy and fx, that two components are equal only when theta is equal to 45. Now, if the given vector Z, is resolved in such a way that if it makes an angle theta with the vertical, so you can see here in this case, the vector makes an angle theta with the horizontal. But if the vector makes an angle theta with the vertical, then this component becomes a cos theta. So therefore, in this case, Fy will be equal to F cos theta, and then Fx will be equal to F sin theta. So horizontal component is not always a cosine component. It depends on where you take the angle. If the angle is with the horizontal, then the horizontal component becomes F cos theta, and the vertical becomes F sin theta. In this case, the angle is made with the vertical components, so that's why that becomes cos, the other becomes sin. So, our easy way to remember is, first you decide where you are going to take the angle, and that component always becomes a cos, the other becomes a sin. So this is about the resolution. So resolution is exactly opposite of the addition of the vector. When we add two vectors, we get a single vector. And now if I split that single vector into two, we are going to get the components, which is called resolution of the vectors.
So the next important concept in vector is multiplication of the vectors, or we call product of the vectors. So there are two types of products. The first is called the dot product of the two vectors, and the other is called the cross product of the two vectors. In dot product, when two vectors are multiplied, we get a scalar quantity, whereas in the case of cross product, when we multiply two vectors, we get a vector quantity. So we represent A dot B, that is dot product of two vectors is defined as the product of the magnitude of the vectors and cosine of the angle between them. Whereas in cross product, it is defined as the magnitude of the two vectors and sine of the angle between them. And since it is a vector, we introduce a unit vector which is perpendicular to the plane of A and B, or A cross B. Now, when the vectors are parallel, when A is parallel to B, theta is 0. So we get the dot product to be equal to AB. And here, when A is parallel to B, theta is 0. So sine term becomes 0. So therefore, the cross product is minimum. When A is perpendicular to B, cos 90 becomes 0. So therefore, the dot product is 0. And when A is perpendicular to B, sin theta, sin 90 is 1. So we get the cross product equal to AB with a unit vector. Now, if I take two vectors A and then B, in terms of the unit vectors having coefficient x1 I cap, y1 j cap, plus z1 k cap, and x2 I cap, plus y2 j cap, and z2 k cap. Then the magnitude of the dot product is given by the product of their coefficient, that is x1 x2 plus y1 y2 plus z1 z2. Whereas the cross product can be measured using the concept of the determinants, where take the unit vectors ijk and then take the coefficient of the first vector, which is x1 y1 z1, and then take the coefficient of the second vector, which is x2 y2 and z2, and then simplify. You're going to get the product of the two vectors, that is the cross product of the two vectors. And if you want the magnitude, use the root of square of the x coefficient plus square of the y coefficient plus square of the z coefficient. So that's how we measure the dot product as well as the cross product. Now, when we consider unit vectors, I dot I. So when we say I dot I, these are two unit vectors along the x-axis, identical, or along the same direction. So theta is 0. That means that the two vectors are parallel. And when they are parallel, their dot product is the maximum. And since these are unit vectors, so I dot I gives 1. Similarly, j dot j, k dot k will be equal to 1. Now, when we consider I cross I, in this case, when we say I cross I, the angle between the two vectors is 0. And that means that the vectors are parallel. And when the vectors are parallel, the cross product is always equal to 0. So I cross I, j cross j, and k cross k is always equal to 0. Now, what if the unit vectors are different? If it is I dot j. When we say I dot j, so I is along the x-axis, the j is along the y-axis. The angle between them is the 90 degree. And when the angle between them is the 90 degree, the two vectors are perpendicular, so their dot product has to be 0. So therefore, this is equal to 0. But when it comes to cross product, I cross j. I cross j, that is angle between them is 90 degree. Again, when the vectors are perpendicular, sine 90 is 1. So we get this cross product to be equal to maximum. But since the product is a vector, we get this equal to k cap. And to find that, you can make use of this diagram, where let me consider this as a I vector, this is j vector, and this is k vector, k cap. And in the clockwise direction, consider that product to be equal to positive, and in the anti-clockwise direction, consider that product to be equal to negative. That is, I in this direction, I cross j, you will get plus k. J cross k is equal to plus I cap. Whereas if I take I cross k, I'm going to get a negative. That is, I cross k is equal to minus j. Similarly, k cross j is equal to minus I, and so on. So therefore, this diagram will help you in finding the relation between the cross product of the unit vectors. And vector A dot vector B is equal to B dot A. That is, dot product is commutative, whereas cross product is non-commutative, which is A cross B is not equal to B cross A. The exact relation is A cross B is equal to minus B cross A. So this is the exact relation. That is, A cross B is exactly opposite direction to that of the B cross A. That means the angle between A cross B and B cross A is nothing but 180 degree. So this is about the products of the two vectors. One is dot product, the other is cross product. So again, an important concept in vectors. And we make use of this dot product, cross product in finding the values of the dot product. For example, to find the work. Work is the dot product of the force and displacement. Power is the dot product of the force and the velocity. Flux, electric flux, magnetic flux is the dot product of electric field and the area vector. So in all these concepts, we can make use of the dot product. Similarly, to find the cross product, we can make use of cross product in concepts like torque is equal to the cross product of the position vector and the force. We can even use this in the case of the force acting on a moving charge, which is F is equal to Q into V cross B, or the angular momentum L is equal to R cross P vector. So in all these concepts, if they give the unit vector, sorry, the position vector and angular linear momentum vector, we can find angular momentum, and to find that we have to make use of the determinants by using the coefficient of R and P. So now we have learned addition of the vectors, the product of the vectors, and the other important concept is subtraction of the two vectors. So I'm going to consider a vector of magnitude p. And here we are going to consider another vector of magnitude q. And I want to subtract vector q from vector p. We want to find p minus q. Subtraction of one vector from the other is same as addition of one of the vector and the negative of the other vector. So subtraction of q from p is same as the addition of the first vector and the negative of the other. So in this diagram, if this is p, if this is q, I can find minus q, negative vector. A negative vector is one whose magnitude is same as that of the given vector, but it is in opposite direction. So this is equal to minus q. And now I have to add the two vectors. To add two vectors, I can make use of the parallelogram. So this is p and this is q, and this is the resultant, and this will give you p minus q. So this is how we can find, we can separate one vector from that of the other. Now, as you can see, the angle between, if theta is the angle between p and q, the angle between p and minus q is nothing but here, it's a 180 minus theta. So we know the formula for the addition of the two vectors, where r is equal to root of p square plus q square plus 2pq cos theta. But here the angle between these two vectors is nothing but 180 minus theta. Therefore, if I replace that here, cos of 180 minus theta. 180 minus theta means it's in the second quadrant, where cos is a negative. So therefore, you're going to get r is equal to root of p square plus q square minus 2pq cos theta. So this is the magnitude of the subtraction of two vectors. This is the magnitude of addition of the two vectors. So that's the difference between the two equations. And I'm going to give you the comparative table where you can remember all the different cases that we come across. So the comparative table is very important. So here I'm going to write the addition of the vectors, and here I'm going to write the subtraction. Okay, subtraction of the two vectors. So the formula for the resultant r is equal to root of, it's a p square plus q square plus 2pq cos theta. Whereas in the case of subtraction, we write r is equal to root of p square plus q square minus 2pq cos theta. When theta is 0 degree, here the resultant is maximum, r max is equal to p plus q. Whereas when theta is 0 degree, when we subtract the vector, we get r is equal to p minus q. So r is minimum when we subtract the vectors. Whereas when we add the vector, r is maximum. When theta is equal to 180 degree, the addition will give you the minimum resultant, which is a p minus q. Whereas resultant is a maximum when we subtract the two vectors. Because cos 180 is the minus 1, minus of minus becomes plus, and you'll get it. So you can see the relation is exactly opposite when we add as well as when we subtract the vector. Now the last case which is remaining is when theta is equal to 90 degree, the resultant is given by root of p square plus q square. Even here, r is equal to root of p square plus q square. That means only for theta is equal to 90 degree, whether you add or whether you subtract, you will get the same relation. So this comparative table is important for the addition as well as for the subtraction of the two vectors. Now, based on this subtraction of the two vectors, we have a few special cases to be discussed. Very important. A man moving with a velocity Vm towards east. So this is south and this is the north. And the rain is falling vertically downward with the velocity Vm. Sorry, with the velocity Vr. So we want to find what is the direction in which the man has to hold the umbrella to protect himself from the rain, for which we have to find the velocity of, that is the relative velocity of the rain with respect to the man. So which is equal to VR minus Vm. So VR minus Vm is same as vector VR plus of minus Vm. So VR is in the downward direction and minus Vm, which is the opposite of the vector Vm. So Vm is towards east, whereas minus Vm is towards west. And the resultant of these two vectors will be along this direction, and that will be the relative velocity of the rain with respect to the man. And if I have to extend it here, so I'm going to get that in this diagram. Somewhere here. So this is the direction of V, R, M. That means the man has to hold the umbrella here in a direction towards east, making an angle theta. And we can find that value of theta. So this is a VR. And this vector here, this vector is Vm. So this is, if I extend it, so this will be equal to Vm. So therefore, tan theta is equal to Vm by Vr. Vm by Vr. So this is how we can find the direction towards which or along which the man has to hold the umbrella, making an angle theta towards the east, and that theta is given by this formula. So this is an important application of the relative velocity. So I'm going to explain one more a special case where we have a river having width W. So this is the direction of the river, which is VR. And a man wants to cross the river having width W. So W is the width of the river. And VR is the velocity of the river. And to cross the river, the man has to swim from one end to the other end. Let's consider Vm is the velocity of the man swimming from one end to the other end. And now the condition is he has to cross the river in this particular direction. Suppose if he starts swimming in this direction. Now there are two velocities are acting on him. One, velocity of the river in this direction, and the velocity of the man swimming in this direction. And the resultant of these two act along this direction. So he will end up reaching the other end of the river somewhere here. But the condition is the man wants to cross the river in the shortest path, shortest distance. And the shortest distance is here. That means the resultant of VR and Vm should be along this direction. And for that to happen, the man has to swim upstream like this. So this should be the velocity of the man, Vm. And this is the velocity of the river, making an angle theta here, so that this V becomes the resultant velocity acting on the person, so that he crosses the river in the shortest path, and the path is W. So if I extend this diagram here, if this is a VR, that's the velocity of the river, even this also becomes a VR. The side is equal to this side. Look at the diagram and see what is the relation between VR and Vm. So it's a right angle triangle here. So we have V square plus VR square is equal to Vm square. So from this, what's V is equal to? It's a root of Vm square minus VR square. V is equal to root of Vm square minus VR square. So therefore, to cross the river, what is the time taken by the man? So time is equal to distance, which is W, by the velocity along this direction, which is V. And what is the value of V? V is equal to root of Vm square minus Vr square. How to find the angle at which the person has to swim upward? So Vr here opposite side, this is the hypotenuse. So therefore you're going to get sine theta is equal to Vr by Vm. Vr by Vm. So all these equations are applicable under the condition that the person wants to cross the river in the shortest path. Now, in the same situation, in the same scenario, if the person wants to cross the river in the shortest time, then which direction the person has to swim? So this is the bank of the river, and this is the direction of the river, which is Vr. W is the width of the river. For the shortest time, the velocity has to be more. So therefore now, the person has to swim in this direction, Vm, so that the resultant act along this direction, so that finally the person reaches the other end of the bank with a resultant velocity V, which is given by a root of Vm square, and then plus Vr square. That's of the format root of P square plus Q square, because the angle between the two vectors is equal to 90 degrees. Now what is the time taken? T. T is equal to the width, which is W, and along the direction the vector is a Vm. So this is how we can find the time taken by the man to cross the river. Then what is the angle made with the resultant theta? So that also we can calculate. So if this is Vr, so this is opposite side, this is the adjacent. So Vr by Vm gives a tan theta. So tan theta is equal to Vr by Vm. So in the previous case, we have discussed a man crossing the river in the shortest path, and this is a situation where a man wants to cross the river in the shortest time, for which the resultant velocity has to be more. Only then he'll be able to cross the river in the shortest time. So let's next learn about the other important concept, which is projectile motion. So what is a projectile? A projectile is a body is thrown into space and then which moves under the action of gravity. So for which we need a point of projection. This is the point of projection, and the direction of projection makes an angle theta with the horizontal only whenever we analyze, so that u with the initial velocity, or we call it as velocity of projection, and then the trajectory is always a parabola, so that it reaches the same level of the projection. By then it covers certain maximum vertical distance, which we represent by h, maximum horizontal distance, which we call it as the range of the projectile. To reach the maximum height, it takes time t, that is a time of ascent, and from the maximum height to reach the same level, again it takes further same time, which is a time of ascent and time of descent, and when you add, you will get the total time, which we call it as a time of flight. Now, certain important points which you have to remember that is applicable for this entire projectile. Now, when we are talking about initial velocity of projection. So what is the initial velocity? The initial velocity of projection is always, it's a u. U is the initial velocity of projection, and that makes an angle theta with the horizontal. So if we use the initial velocity of projection, what is the final velocity with which it reaches the same level? So here also it reaches the same point with the same magnitude. So velocity with which it reaches the ground is same as the velocity with which it is projected. So therefore here the velocity is u. Only difference is the directions are not same. Here it makes an angle theta with the horizontal, and here also it makes theta with the horizontal. So directions are different, but magnitude is same. Now along the horizontal, what is the initial velocity? Initial. So which I can write as ux, and the value of ux is the horizontal component, which is u cos theta. That is the horizontal component. Now this is the initial velocity. This is the initial horizontal velocity. Okay, initial. What is the initial vertical velocity? So initial vertical velocity is a uy, and that uy is nothing but u sine theta. Now this initial velocity I can resolve into two components. One, the initial horizontal velocity, which is ux is equal to u cos theta. Along the horizontal, there is no effect of gravity, so that's why the acceleration is 0. So the nature of motion of the projectile along the horizontal is uniform velocity. Whereas along the vertical, since the projectile is under the effect of the gravity, the acceleration is equal to minus g, which is because it's thrown vertically upward, so it's equal to minus g. So what is the initial vertical velocity? So when we resolve u along the vertical, it becomes uy, which is u sine theta. So ux cos theta is the initial horizontal velocity, and uy is equal to u sine theta, which is equal to initial vertical velocity. And projectile motion is a combination of uniform velocity along the horizontal and uniform acceleration along the vertical. Now when the projectile reaches the maximum height, so this is at maximum height. At the maximum height, what is the velocity of the projectile? Is it 0? No, because if it is 0, the projectile falls back to the ground. It is not equal to 0. It is along the horizontal. That means there will be only horizontal component. But since we already know that along the horizontal, the body moves with uniform velocity. There is no acceleration. So therefore, what is the value of the velocity along the horizontal at each and every point? It is always is equal to u cos theta. So this is one of the important points which you have to remember. That means this u cos theta is not just the initial horizontal velocity, but it is the velocity along the horizontal at each and every point. Suppose at this particular point, what is the horizontal velocity? I can definitely write to u cos theta. What is the velocity at this point? Again, it's a u cos theta. What is the velocity here? It's u cos theta. At each and every point on the projectile, the horizontal velocity is u cos theta. For what reason? Because there is no acceleration. The nature of motion of the projectile is a uniform velocity along the horizontal only. So that's why the horizontal component remains the same at each and every point. So that's why I can use this horizontal velocity as u cos theta at each and every point on the path of the projectile. So therefore, at maximum height, what is the velocity along the horizontal? You can write Vx velocity, because I'm writing final velocity. Vx is equal to u cos theta. What is the vertical velocity at that point? Since the vector is horizontal, its component along the vertical is 0. So therefore, there is no vertical component when the projectile reaches the maximum height, which is equal to 0. So at the maximum height, the horizontal component is u cos theta, and the vertical component 0 at the highest point. So these are the velocity relation, or the velocity at each and every point of the projectile, which is very important because a lot of equations related to the projectile we are going to write based on these equations. So let's write some more equations related to the projectile. I'm going to start with the trajectory of the projectile. So let's consider this is a projectile projected with a velocity u, with an angle of projection theta. R is the range of the projectile. H, capital H, is the maximum height. The trajectory of this projectile is given by y is equal to ax minus bx square. Now this equation is used to find the position of the projectile at any given instant of time. Suppose if you want to know what is the position of the projectile at this particular point. So then this will be the value of y. This will be the value of x. Y and x can be substituted. What is the value of a and b? So a and b are constant. So a is equal to tan theta, where theta is the angle of projection. What is the value of b? B is equal to, that is g. It's yeah. So g x square by 2u square cos square theta. So that's the value of b, not x square. Sorry, it's a g by 2u square cos square. So that's the value of b. So therefore we have a is equal to tan theta, and then b is equal to, correct. So g by 2u square cos square theta. Now by dividing a by b, we are going to get the range. R is equal to a by b. And what is that a by b is equal to? It is u square cos 2 theta by g. So if these coefficients, that is a and b, are divided, you will end up getting the formula for the range. So range is given by a by b will give you a u square, that is it's u square sine 2 theta by g. Sorry, R is equal to a by b u square sine 2 theta by g, which we can even write like this, which is 2 u square sine theta cos theta by g will give you the value of the range. The other equations related to the projectile are one, time of flight. Time taken by the projectile to reach from the point of projection to the maximum height is called time of ascent, which is also equal to the time of descent, which is given by u sine theta by g. And time of ascent plus time of descent will give you time of flight, which is t is equal to 2u sine theta by g. That's 2 times. What is u sine theta? U sine theta is nothing but the vertical component, which I can even write 2uy by g. So this is the formula for time of ascent as well as time of descent, and this is equal to time of flight. So time of flight is also equal to time taken by the projectile to reach from the point of projection to the same level after reaching either the ground or even the same level. Or we can even call it as the time taken by the projectile to cover the maximum horizontal distance. Time taken to cover the range is also called as the time of flight. So what is the equation for maximum height? Capital H. H is given by u square sine square theta by 2g. And u square sine square theta is nothing but again the vertical component. So that is u y square by 2g. So that's the maximum height. And h is maximum. H is maximum when the projectile is projected vertically upward. That is theta is 90. So when theta is 90, the projectile will move upward like this. Thereby it reaches the maximum height. And when theta is 90, this term becomes 1. So we get u square by 2g. So this is when theta is equal to 90 degrees. So that's the maximum height covered by the projectile. So we have the term range. So range is given by r is equal to u square sine 2 theta by g. Now that's equal to 2u square sine theta cos theta by g. If you can check here, we have u sine theta and then u cos theta, which is also twice the initial horizontal velocity and then the vertical velocity by g. You can even find this range using the time of flight. That is, along the horizontal component is u cos theta. That is the velocity into time taken, which is t, or that is also equal to u along the x-axis and then the time of flight. So using the various equations, you can find the value of the range. The range is maximum. So this is for maximum range. R is maximum when the angle of projection is equal to 45 degree, when theta is 45. When theta is 45 degree, we get R max to be equal to, in this case, sine 45 will get into 2, sine 91 will get u square by g. And when we substitute in h, u square sine square theta by 2g, u square sine square theta, that is sine 45, and square 1 by root 2, square is half. And then already there is a 2, so I'll get 4g. That's u square by 4g. When we make use of t, it's a 2u sine theta by g. 2u sine 45 by g. Sine 45 1 by root 2. So we'll get root 2 u by g. So these are the values of the maximum range and the height covered and the time of flight. And we can even relate here. If you can check here, R max is equal to u square by g. And from this u square by g is nothing but 4h. So therefore, maximum range is equal to 4 times the height covered. Similarly, we can find the time of flight. T is equal to root of 2 and then u by g. From here, we can get it as R max by g. So these are the relation applicable only for maximum range. Now there is a relation between maximum range and the height covered. That is, R max is equal to, it's a 4h cot theta. Now this is the relation between the range and the height. R is equal to 4h cot theta. If R is equal to h, if R is equal to h, then cot theta 4 or 4 cot theta is equal to 1, or 4 is equal to tan theta, or theta is equal to tan inverse of 4, and you'll get that nearly equal to 76 degrees. So this is one of the special cases which you can remember, that range is equal to the height only at an angle of 76 degrees. Then R is equal to 4h. R is equal to 4h when cot theta is 1. And cot theta is equal to 1 when that is also tan theta is equal to 1, or when theta is equal to 45 degrees. So when theta is equal to 45 degree, range is equal to 4h, and when theta is equal to 70 degree, the range is equal to the maximum height reached by the projectile. So in projectile motion, how to find the velocity of the projectile at any instant of time, instantaneous velocity. So let's find that at a particular instant, I want to find the velocity of the projectile at a given time. So our job is to find first the velocity along the vertical. So I'm going to use the relation v is equal to u plus at. So first find velocity along the vertical, which is vy. Then velocity, initial velocity along the vertical, which is uy. And then minus g into t. So this is using the relation v is equal to u plus at. This is vy, and we know the value of uy. What is the initial velocity along the vertical, which is u sine theta minus gt. So this will give you the vertical velocity. Then find the horizontal velocity. Horizontal velocity is same at each and every point. What is that equal to? It's u cos theta. Now, this velocity along the vertical, this velocity along the vertical, sorry, horizontal, and now we can find the resultant using root of vx square plus vy square. So this is how one can find the instantaneous velocity of the projectile when we know the time factor, most important. So only when we know the given time interval, then these equations are replicated. Now imagine if the time factor or that variable is not given, but instead height is given. At a particular height, what is the velocity of the projectile? For which we are going to make use of one more equation of motion. That is v square is equal to u square plus 2as. Since height is given, we use this particular. So first let's find the velocity along the vertical, which is vy square is equal to uy square minus 2gh. So using this, we can find the vertical velocity. So what is the horizontal velocity? Vx, it is a ux cos theta at each and every point. And now we can find the result. So v is equal to root of vx square plus vy square. That's a root of vx square is nothing but ux square cos square theta plus what is vy square? Vy square is nothing but uy square, and the value of uy is nothing but u sine theta and the square minus 2gh. So square here. What is the ux square cos square theta? So this is the value along the, so this is along horizontal ux square, where is it? Yeah. So this is along the horizontal, yeah, which is nothing but u only. Okay, that's u square cos square theta, and this is nothing but u square sine square theta, which is the vertical. Okay, so from this what we get? U square is common. So when u square is common, we get cos square theta plus sine square theta, which is equal to 1. So therefore we get u square minus 2gh. So this is the velocity when the factor height is given. So this is how we can find the velocity of the projectile at any instant of time. When t is given, we make use of v is equal to u plus at, and when height is given, we make use of u square. V square is equal to u square plus 2as. We can even find the energy of the projectile at every point. So let us consider initial point. Initially, at initial point, what is the energy? When it is projected with reference to the ground, the kinetic energy is half mu square. Now this is the initial kinetic energy, and its potential energy is always 0 because it's on the ground, and potential energy is of the format mgh, where h is 0, therefore u is 0. So therefore the total energy, which I'm going to write as E, is nothing but half mu square. On adding k plus u, you will get. So therefore this is the kinetic energy, this is the potential energy, this is the total energy. And when it reaches the maximum height, so this is at maximum height. So at the maximum height, it has velocity, therefore there will be kinetic energy, and that's given by half m, and its velocity here is a u cos theta. So square of it, u square cos square theta. Out of which, so this is k dash on it, right? Out of which this half mu square is nothing but its initial kinetic energy. Therefore, I can even write it as Ki cos square theta. So this is how we can find the kinetic energy at the maximum height. So what is the potential energy at that point? It's m, g, and then h. Where I can use the height relation. H is equal to u square sine square theta by 2g. So therefore, gh is equal to half m u square sine square theta. So again, half mu square is nothing but the initial kinetic energy. So I can even write it as Ki sine square theta. So kinetic energy at the maximum height is given as Ki cos square theta, where Ki is the initial kinetic energy, and potential energy at that point is given by Ki sine square theta, where again Ki is the same initial kinetic energy. So what is the total energy at that point? So for which we have to add these two. So E is equal to K dash plus U dash. And when I add Ki cos square theta, Ki sin square theta, Ki is common. And cos square theta plus sin square theta becomes 1. And we get Ki, which is equal to half mu square. And it has to be half mu square only. Why? Because we know that the total energy of the system remains constant. So therefore, what is the initial total energy? It is half mu square. Even when the body reaches the maximum height, its total energy remains half mu square only. So this is how we can find the energy of the projectile at any point. Even if you want to find the kinetic energy, find the velocity, as I've explained earlier, as how you can find the instantaneous velocity, and then multiply by half m, you will get the kinetic energy at that point. And then subtract from half mu square, you will get the potential energy. So half mu square is the total energy at each and every point of the projectile. So this is so these are the important quantities which you have to remember. One, the trajectory of the projectile, the time of flight, the range of the projectile, the maximum height, the relation between the range and the maximum height, and then finding the velocity at a particular instant of time when time t is given. Then we can even find the velocity of the projectile when h is given and the kinetic energy. So these are important formulas. Now there is a more concept related to the projectile, so which I'm going to explain in my next session. Thank you.